Hello students, how are you? Hope you are doing well with your studies. I am Professor Umesh Gaikwad, Department of Information Technology, K.K. Wagh Institute of Engineering Education and Research, Nasik. As you know, we have already started unit number 4 in the classroom. Now in today's session, we will check next part of unit number 4 and our today's topic is Basic Smart Wearable and Implanted Devices. Before starting our today's discussion, we will check objectives of the session. First objective is to understand the concept of wearable and implanted devices. And second objective is to compare various smart devices depending on their individual characteristics. For this particular presentation, I have used the book Ubiquitous Computing Fundamentals, author is Stephen Postland. We will start with our topic. In the devices, there are three main types. We can categorize smart devices by using these three types. First type is accompanied, second one is wearable, and third is implanted. Accompanied is a type of devices which are external to the body and which we can carry easily and comfortably. Can you guess those kind of devices? Smartphone is that kind of device which you can carry easily. Some other examples are smart card and smart key. No need to wear, no need to implant. We can carry it easily. We can keep this kind of devices in our pocket, and these kind of devices are small in the size. Second type is wearable technology. These devices are also external to the body, but it is necessary to attach these devices on the body or to the body. For example, smart band is an example of wearable technology. And third type is implanted devices, and those devices are part of our internal body. We will check it one by one. First of all, we will check wearable computer interaction. Devices can be embedded, and as I said, no need to put this kind of devices inside the body. Only thing is that we have to attach it to the body. How can we define this kind of devices or wearable computing? There are three criteria to define wearable computing and wearable devices. First criteria is eudaimonic criteria. According to this criteria, your all smart devices or wearable devices must be within the user space. It means it must be attached to the user body. Though these devices are external, but their connection must be there with the user's body. It means as per the English meaning of wearable, we can wear it. Second thing is that existential criteria. With respect to this criteria, user can dominate or user can control these devices. These devices will be there with user 24/7. These devices will act as an observer for the user, will record the physical behavioral and other behavioral aspect of the user. But if user want to stop the recording, if user want to reconfigure these devices, then user can. This criteria is called as existential criteria. Last criteria is ephemeral criteria. According to this criteria, responsiveness characteristics is very important. You cannot say that user will take delay or 10 minutes delay or 20 minutes delay for providing. User will use a device and that device will take some delay for providing response. No, device should be responsive. Device should take very short delay or no delay while providing the response. So within a short span, that device should provide information to user which is demanded by the user. Next, we will check some unique examples of wearable computing. First example is head-up display. There are two types of head-up display. First one is fixed head-up display, and second one is head-mounted display. In the fixed head-up display, this display element can be part of airframe or can be part of vehicle chassis. As I said, in second case, it can be part of vehicle chassis. It means this kind of devices are available in smart cars. Second type is head-mounted display. This system or these devices are implanted or mounted on the user's head. User can wear these devices over the head, and these devices monitor the user direction of a gaze and determines the appropriate image accordingly. As shown in picture, the image shows that example of head-up display. Now in second type, we will check eye tape. Eye tape is a kind of wearable device. In eye tape, device shows image to both eyes as well as to the computer. At the same time, it shows image to two elements. Why it is possible? It is possible because of beam splitter. Eye tape uses a beam splitter to send the same thing to both eye and camera. The camera then digitizes the reflected image of the scene and sends it to the computer. The computer processes the image and sends it to the projector. The projector sends the image to other side of beam splitter so that this computer generated image is reflected into the eye to the superimposed on the original scene. This is overall working of the eye tape. Now we will check next example, virtual retinal display. Virtual retinal display, this kind of devices are useful in the domain of virtual reality. These devices we can wear these devices over the head, and some part of these devices will be in front of eyes. But these devices have some limitations. Those limitations are these devices are able to carry or able to capture only limited part, and second one is because of heavy weight, these devices are not so much compatible. Now, last thing is that last and very interesting example in wearable computing is clothes as a computer. Yes, clothes can be act as a device, but clothes as a computer, these type of devices are really unique. In previous devices, we have used very less number of sensors, but in clothes as a computer, we have to create network of many sensors. Those sensors will capture the data of user's behavior and will send it for the particular decision. So what kind of sensors will be there? Sensors like accelerometer, temperature, motion related sensors can be part of this environment. So while for designing a clothes as a computer, certain challenges are there. We are going to put some sensors and we are going to integrate those sensors to form a network. So how to form a network? Where should we put number of sensors? What kind of role of each sensor? This is a challenging to decide the fact. Next one is what kind of clothing material is useful for this kind of environment. This is second challenge. And last one is, it is very important when we are saying that my cloth will act as a computer, then to decide size of and material of the sensor is one more challenge. Now we will see next thing, that is implanted devices. Yes, device can be implanted inside the human body. Some really popular examples are pacemaker, which can be implanted, which we can implant with the heart, and very popular in the medical field. Artificial limbs is another example. One more very well-known example is lens, which we can insert into the eyes to get more clear picture. So these are some well-known examples. But other than this, some other examples are also present, which we can see in implant category. First we will see BCI, that is brain computer interface. If you know, then good, but if you don't know, then I would like to tell you that our human brains can generate electrical signal. The type of signal, as I said, is electrical, and those kind of signals is called as the electroencephalograph kind of signals, EEG signals. Main thing is that, is it possible to capture those signals? Yes, it is possible to capture those signals, and it is also possible to analyze meaning of those signals. Now, these signals are physiological signals which represents our thoughts, our emotions, and our feelings. So, the basic technique is that to capture these signals, and after capturing this signal, utilize this signal for particular decision. For that purpose, we need some kind of techniques. It means if you want to communicate with brain, then we need some kind of devices and technique. First technique is invasive technique. In invasive technique, through the surgery, we can implant some electrodes near our brain. Those electrodes will capture our brain signals and will send it for the analysis purpose. By using that analysis, we can take some decisions in medical sector. This kind of technique is very popular in medical field and not so popular in other fields. The problem with this technique is that it needs surgery. In this technique, we have to implant electrode near the brain, so it is very risky technique under the BCI. Now, next technique under the BCI is non-invasive technique. Under this technique, no need to implant device near the brain, or no need to implant sensor near the brain. It is the alternative option to the first invasive technique. Invasive technique is purely implant device, purely belongs to the implant device category. Non-invasive technique is not so much, belongs to that category. In non-invasive technique, we can use wearable device. That wearable device can have some electrodes which we can put over our head. Those electrodes will be able to capture EEG signals, and we can use those EEG signals for our particular purpose. So the question is, is it really necessary to put more number of electrodes to get more data? Yes. Less number of electrodes means less data. More number of electrodes means more data. If you want to get more good analysis of a data, then we need more number of electrodes. So another advantage of this non-invasive technique is it is secure as compared to first technique because surgery is not necessary. And the last one is it is useful in various applications in various domains, just like medical field, after that transportation field, or users performance analysis field. Many fields are there where this technique is usable. Next implant type is sense of presence and telepresence. In the sense of presence, people can experience alternative realities depending on type of environment. So after sensing this alternative realities, people can see the one kind of virtual environment in front of them. Telepresence is again same kind of technique in which set of devices will be there, and people will feel that they are at the remote place, and they augmented reality and virtual reality, these are the domains where these kind of devices are useful. So this is the end of our today's topic, wearable and implanted devices.